Okay. No, what's going on? Ah, there we go. Sorry, I just got a little icon on the camera of what looked like a Christmas elf sneezing stars. So, there we go. So, we're on to the essay. This is Component 3 Mock, number 1. And the essay looks an absolute nightmare. It's got a pile of information and a load of graphs. Oh, what's not to like? So, what does it tell us? Frogs have a larval form called tadpoles, like you didn't know. Of course you should know that. As tadpoles, they obtain oxygen from water, which has a low oxygen content. And that looks pretty much like a dissociation curve to me, so I'm thinking with my little pencil, that's probably important. As adults, oxygen is absorbed from air in simple lungs. This change is accompanied by changes in the properties of the haemoglobin. So the haemoglobin is going to be different in larval and adult frogs, which is similar to that observed in fetal and adult haemoglobin. So already I'm kind of thinking adult, and then I'm thinking, fetal. That curve, that shift to the left. Both larval and frog haemoglobin adult frog haemoglobin can adjust to changing oxygen demands and availability. The graph below shows the effect of pH on haemoglobin from tadpole and adult frogs. So the first thing to sort out is which are your adults, which are your tadpoles. So these dotted lines here, they're the adults. And I'm writing in pencil deliberately because I've got a rubber in case I need to rub something out. And as pH goes down, so as it gets more acid, it shifts to the right. I'm already thinking then Bohr shift. And then these, they look fairly similar to sort of myoglobin to me, really, in a way. But these are shifts then to the left. And as pH goes down, it shifts further to the left. So already I'm thinking low oxygen, I'm thinking high affinity of the haemoglobin, and I'm thinking full saturation. And here Bohr shift is about oxygen release, tissues and respiration. That's what that shift to the right is about. So they're all things that I think should probably be in my answer. That's before I've looked at the question. So, you should be thinking, what do I think they're going to ask? So it says, with reference to the information provided, so that's this and this, explain how the properties of haemoglobin, we're going to talk about those curves, enable tadpoles and frogs to gain the oxygen required for survival. So realistically, I'm going to sort of split it up into 3 areas. So I'm going to talk about the adult. I'm going to talk about the tadpole. And I'm going to talk about environment and oxygen availability. And they're just my sort of 3 areas that I decided would be good. Don't get too hung up on the 3 areas. Obviously you should try and cover the 3 areas, but if you can't think, and I think it's a lot more clear now. I know that there's sort of, we've had 2 or 3 exam papers. It seems to be getting to us to be much clearer what the 3 areas should be that you're talking about. If you absolutely can't sort it out, just write everything you know. Write everything you know. And just keep linking it back to the question. So with adult, I'm going to talk about haemoglobin. I'm going to talk about lower affinity. I'm going to talk about the Bohr shift. And I'm going to talk about why the curve is to the right of the tadpole. And I'm thinking that they've got lots of oxygen, yeah? So if that means low oxygen, then these must have lots of oxygen. And I'm going to talk about release, and I'm going to talk about respiration. Because that's what I know. That's what I know. I don't know anything about frogs, really. They're lovely. Tadpoles. So what I know about tadpoles is you start off with a tank full, you end up with one big fat carnivorous one. Anyway, that aside, as far as oxygen dissociation curves go, what do I know? That left means low oxygen, that the haemoglobin has a higher affinity, that I'm going to be talking about full saturation. Now I'm going to have to at some point address why when the pH drops, so pH drops usually you get shift to the right, why it's shifted to the left. So I am going to have to address that at some point in the essay, and I need to probably have a think about it. So what am I currently thinking? Probably be thinking a lot more if I had access to the mark scheme, but anyway, there we go. Environment and availability, we're told that the tadpole has a low oxygen environment. And obviously if anything changes, what do I know myself about water? That if the temperature increases, or you've got lots of decomposing stuff, then all of those will make the oxygen fall. So presumably this acidity then has got something to do with that curve shifting to the left. So if that condition in the pond, stream, river, wherever they are, changes, then they might need to, the oxygen might fall, and therefore you've got a shift to the left, so that it still becomes fully saturated. And what can I say about the adult frog? It's got lots of oxygen, so the curve is to the right, doesn't get as saturated. And then you've got this link to activity and respiration. And I think actually if you sort of wrote a little paragraph that sort of explained all those things, that you should do well. You really should. They're not asking you something you don't know, whatever context it's in. Write a good paragraph, well explained, link back to the question, how it's going to get enough oxygen. Well, the tadpole's got this high affinity, so therefore it can survive. If the oxygen levels fall, there's a further shift to the left, which means that they can still fully saturate. It's not, I think, don't tie yourselves in knots with it.